This is a replica of Van Leeuwenhoek's microscope. Look how simple it is. It's just a piece of brass, and it's got one tiny hole with the lens in it, which is maybe 1 millimetre across. Yet this is the gadget that transformed the way we see the world. A tiny lens, yet more powerful than any other. Van Leeuwenhoek knew that it's the curvature of a lens that bends the light passing through it, so making the object being observed, here it's a flea, appear larger. And because Van Leeuwenhoek was a master craftsman, he could curve the lens more than anybody else, almost to the point it was spherical. This allowed him to magnify objects up to 500 times. No one would make a more powerful microscope for over a century. So he now had the technology, but what did he look at? He went from linen to fleas to the sting of a bumblebee. In fact, pretty much anything he could get his hands on. And one of the things he looked at was water. He'd noticed that in a lake near Delft, the water changed colour with the seasons. And he figured that there might be something in the water that he could discover. Many of the fundamental breakthroughs of science seem so simple, so absurdly simple. But we shouldn't forget that until Van Leeuwenhoek, no one had the curiosity to find out what might be lurking in the water. He raced home to take a closer look with his microscope. The man who's going to help me study the water is Hans Lonke. He keeps the spirit of Van Leeuwenhoek alive by making replicas of his microscopes. To grind a lens, Hans needs no special glass, just a shard from an old jam jar will do. The only way to get enough curvature in the lens is to make it tiny. This was Van Leeuwenhoek's secret, and it requires great skill and patience. Van Leeuwenhoek built a staggering 247 microscopes, a new one every couple of months for over 50 years, and told nobody how he made them. We've placed a drop of my lake water onto a slide that slots into the device. With a bit of luck, I'll be able to see what Van Leeuwenhoek saw. Now, I've looked down a fair few microscopes in my time, and this is nothing like anything I've used before. It's fiendishly difficult to use, so I've got Hans with me, just in case I can't see a thing. So, what do I actually do? Where am I looking?
At the wrong side, you must look through this hole.
Yep.
A very tiny hole. There's a lens in it.
Yes.
And the lens, through the lens, you see the sample that is put between the glass.
So if I hold it up to the light, like this.
Close to your eyes.
And I can see... I can see green.
There is a focusing knob.
There's a focus?
Yes, there is a focusing knob. This might be made...
So I can move it actually away from my eye?
This one, this is the focusing knob.
It's so simple and it works so well. Yeah, that works. That really works. It's now in focus. Oh, wow. Oh my God, you can actually see moving creatures.
Yes.
Oh God, that's incredible.
We all know the drill. Arrive at the desk, tag your bag, print your boarding pass, and head through security. Finally, you make it through. Get the obligatory supersized chocolate bar in duty-free, and then time to find the gate. Board the plane, and get ready for takeoff. That's all there is to it. It's all very familiar. But behind the scenes, there's a hidden world of complexity. Take your suitcase. Once you've checked in, your baggage sets out on its own long and secret journey before eventually joining you on board. Here in Dubai, they handle enormous volumes of luggage. In just 3 hours during the morning rush, they process around 50,000 bags. Stacked like this, they'd reach as high as Dubai's Burj Khalifa, the tallest building in the world. Annually, the airport handles a staggering 57 million items. That's equivalent to 1,100 Burj Khalifas. And it's all got to be whisked through the airport. Every bag must get to the right plane at exactly the right time. To make sure that happens, each individual bag needs one of these. The humble bag tag. So on your baggage tag, which we've all seen obviously, you've got things like your name, and then here we've got the DXB, which is a 3-digit code for the airport that you're heading to. But the really important thing is this mysterious 10-digit number along the bottom. This is like your bag's passport number, if you like. So the digits identify the airline, your particular bag's ID number, and then there's a special message digit which identifies the priority of the bag or any other information they need to know, high priority, low priority, that kind of thing. This code is part of the universal language of aviation, an international system that knows no borders. And it determines exactly what will happen to your suitcase after check-in. 25 meters beneath the airport lies a bizarre subterranean world. A sprawling 85-mile high-speed railway network. Costing around £500 million to build, this is the world's biggest luggage system. This place is absolutely enormous. Everywhere you go, there are just miles and miles of these conveyor belts, of these trays that carry the suitcases moving along. It's really weird. It's like some kind of post-apocalyptic fairground ride. But the strange thing is you don't see any human beings. It's completely automated. It's like the robots have taken over. After check-in, your bag is spat onto a yellow tray. Each tray has been chipped with a unique ID, and a computer tracks which bag has landed in which tray. So each tray is specific for each bag?
It is, yeah.
Okay,
so instead of tracking that bag, we track
you track a tray instead, I see.
And that tray has an ID, which allows us to track it 100%.
The human being tasked with keeping an eye over this vast system is baggage manager Graham Pollock.
What we have around various points in the baggage system are what you see here is some read stations.
This thing here?
This thing here. This sensor will pick up the information from the tray. So the tray knows where it's going. It will tell this part of the baggage system, and here I am, please send me to this location. And then the baggage system will then divert it to the necessary output point.
The computerized brain of the luggage system plots every inch of your bag's journey to the aircraft. If your flight's leaving within an hour, the computer sends your baggage straight to the loading area. But for those of us with better timekeeping, our bags end up here, the early baggage storage system. If you've checked in a little bit too early, what happens is the bags will wait here, and then as soon as it's time for them to make the journey to the aircraft, a little red robot shuttle will whiz along here, pick up the tray and put it on the conveyor belt system, and then away it goes. Look, there goes a robot. The sheer volume of baggage moving through here is breathtaking. It simply can't be allowed to fail, so it's monitored constantly from the control room. There are more people working here than on the entire length of the conveyor system.
Copy the 886 and 374, you need to clear it fast, please. If it's taking time, let me know, please.
Can you just explain a little bit about how this works? Because it looks like a full-on something you might find in a railway network. It looks incredibly complicated.
Basically, you can see that right now red, yellow and green. Green shows the system is normal, basically, the green color. So red shows a fault.
And there's also yellow as well.
Yeah,
so what is yellow?
Yellow is basically a queuing where the bags waits.
So it's basically like a traffic light. Green, good.
Yes,
yellow,
yes,
might have a problem. Red is like, ah!
I'm about to enter a very different world. David Margolis is an artist, historian, and devotee of the colour blue. In his London studio, he works with some of the rarest minerals and pigments on Earth. Among them all, the most spectacular are the blues. And one blue in particular takes pride of place on his shelves.
This is a piece of lapis lazuli that's come from the one mountain in Afghanistan.
So the important thing here is this blue colour, and that is lapis lazuli.
It was the most precious and most expensive of all the pigments.
There aren't many blue things in nature, so this must have been a spectacular thing to display and to find.
Someone had walked through the mountains of Afghanistan and come across blue stone, and it makes me wonder whether they believed that the sky had fallen to the earth and turned to rock.
I love that idea, the sky that had fallen into a rock. That's exactly what it looks like, isn't it? The colour is so stunning. I can imagine the impact it must have made when lapis first arrived in Europe, when trade routes from the east opened up.
It was seen as extremely valuable. In Renaissance Italy, it was so expensive it was the equivalent of the price of gold.
To have this was a status symbol, and the most visible way of having it was to put it on a painting, because you could paint this colour onto a big canvas and show that you had this commodity. So it's not a subtle way of displaying your status. It's saying for everyone to see.
I don't think it's subtle at all. I think the most important aspect is that lapis does have a slightly mystical quality. So when it came to painting, quite often the blue was used to paint the robes of Mary. Probably the most famous artist to have used it is Titian.
There's something entrancing about this colour. But to discover what it can tell us about our planet, I need to do what painters do and get right inside this rock. An artist is presented with a lump of this rock, and they have to make paint out of it. What do?
They hammer it.
Not very sophisticated.
Hammer it until it gets smaller and smaller.
It was quite satisfying, this. This is the first time it's been a colour, because this has never seen daylight before. That bit of rock I've just smashed had just become a colour for the first time. So the next one along, so now we've got lots of broken up little bits. And you can start to see blue powder.
That's right.
And that's what the pigment is, it's the powder when it becomes a powder.
That's right.
Oh, that's a horrible noise. It's such a horrible noise.
And you might smell it as well.
Oh, there's a really strong smell of sulphur.
It is sulphur. Sulphur is what makes the rock blue.
And then the final stage, when it's broken down, is what we've got in the last one here. This is the bluest thing I've ever seen. It's the chemistry of this rock that creates its colour. Sulphur more often produces yellowish compounds. This is lovely, lovely stuff. But in lapis lazuli, the unique combination of sulphur with other elements produces this deep, rich blue we call ultramarine. And this is it. This is the final step. The blue powder has been mixed with oil and some wax, and it's a paint. And so this rock that looks like it fell from the sky is becoming sky all over again. When we look at this, we just see a blue rock. But the secret to that colour, it's hidden in the atoms that make this up. But the atoms themselves aren't enough. To get this, you need to transform them. For a transformation to this dramatic blue, you need the sorts of pressures and temperatures with which planets are forged.
And this is it, a giant raised canal or aqueduct. Currently the largest engineering project on Earth. The Chinese are constructing the aqueduct on site, piece by piece as they go, in separate 50-meter-long sections. Each one starts off as a giant framework of steel rods. A team of 20 men build this bird nest-like skeleton, and the whole structure is encased in concrete. Then it's ready to be moved into position with one of the world's most powerful cranes. Each section weighs 1,200 tons, more than 3 jumbo jets. The 25-year-old crane driver, Guang Ah-feng, isn't daunted by it all.
我感觉我都没想到我能参加这么大的项目，因为我平时都干的是那种小的那些，也不是说小的吧，反正就那种纷纷过来参加这么大的工作，然后还能吊这么大的车，开这么大的车，吊的是这么大槽，然后作为一个女孩子来说，感觉非常幸运，荣幸的很感觉。
Building a man-made river across the landscape takes more than just brute force. Positioning the blocks is critical. The water has to flow north to Beijing of its own accord. There are no pumps. So Guang Ah-feng has to set the gigantic block at the perfect gradient, just a centimetre lower at one end than the other. The aqueduct is so long, it won't be fully operational until 2030. When it's carrying water, millions in northern China will benefit. The need to move water to where people live has led to giant engineering projects across the world. But it's our need to feed ourselves that's really transformed the face of our planet.
We need to get ready to go, don't we? Push!
For 8 years, the Nation family have been consumed by an obsession.
So 73, 98, 97, 69, 98, 100.
They've left their home on the southeast coast of England to live in the cold climes of northern Norway. Spending their weekends chasing the planet's most extraordinary and colourful phenomenon. The Northern Lights, or the Aurora Borealis.
It's an addiction, it's an absolute full-blown addiction. It's a buzz and it's a rush of adrenaline and it's a holding of your breath and wow.
The Aurora Borealis is a light show like no other.
Let's see if I can find a corona. Okay, this is a corona. You get this purple or pink in the centre, then the green comes out of the purple, and then the white part that you can see is where it almost overexposes, and that's the part that tends to move very quick. Our eldest, Aurora, she's 11, She's fascinated by why do those different gases make those different colours. Oshi, she likes the pink because she likes pink, it's her favourite colour. And Lyrica is quite a fact box on everything. She can explain to you what causes an aurora, where it comes from, the technical names, and you know what the magnetic field does and how it stops the solar wind from harming us.
The aurora's ethereal colours are created when energetic particles from the sun interact with the Earth's upper atmosphere. When they strike gas atoms, the energy makes those atoms vibrate, and photons of light are released to dance across the dark night sky. However, the aurora can be elusive. To see it from Earth, conditions have to be just right.
Part of the fun is succeeding against the odds. And we've gone out in weather like this and then it's suddenly cleared and then the skies have suddenly opened up.
Shall we go build a snowman?
To give themselves the best chance, the family pick a spot and set up camp under the stars.
That is not a bad fire, is it?
That's on the flame. Mama, you're going to burn it.
Careful, Louis. Don't lean too far forward.
I think that's enough.
They wait,
Will you hold it just
sometimes
there? That's
for
the best
hours.
place to hold your sausage. That's the hottest part.
Is it? How?
It wasn't a Bunsen burner.
The chances of seeing the aurora borealis are greater up here within the Arctic Circle because the charged particles streaming out from the sun are drawn towards the magnetic North Pole.
Oh, 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 oh. I can see some uprights there.
Here we go, look at it.
Beautiful. Look at it. Look how bright that is up there, look. Yeah! Yes! Now that's what I'm talking about. Look. Ooh. Look. Corona, Corona. Look at it. Stunning.
Wow. Oh, oh, oh!
It's so much better.
And on the left, look, there's some pinks at
Yeah,
the bottom.
it's gonna do Corona. Look.
But the aurora isn't simply beautiful. The colours are a code to the physical world because they reveal the chemistry of our skies. Each chemical element is unique, and each one gives off photons of a particular colour. The green comes from oxygen atoms, purple from nitrogen. The light shimmering across the sky reveals the oxygen and nitrogen-rich atmosphere that envelops our planet. This kind of coloured light doesn't only tell us about our world, it has also shown us the universe.
The idea of hanging over boiling lava seems more than a little crazy. But the rock and gas samples from deep within the crater are the final pieces of the puzzle Shane needs to understand what this volcano is doing.
So you ready to be a guinea pig?
I am.
these are like dipsticks in that, you know, they're a glass tube, and I'm going to break off the end.
Yeah.
And then during your descent and return, over that period, the gases that you encounter will react with the chemical on the foam in here. I'm going to put them facing downwards so they don't get ash in them.
Okay.
And when you get back, we'll take them off and see how much gas you've been breathing.
Thank you.
Rightio, we're ready to roll.
Squeeze that lever.
Once we're clipped in, there's no turning back.
So, feet as wide apart as possible.
Yep.
That'll give you lots of balance.
We plan to abseil down this near vertical drop to a ledge above the boiling lake of lava.
Excuse me.
Oh, no, don't worry at all. We'll be doing to each other all the time. We just smash into each other.
If we're successful, it will help give us a new insight into the inner workings of this volcano.
I have to confess that all I'm looking at the moment is my feet and Tim's feet. I haven't looked around me, I haven't looked at the view. I think if I did, I would be stuck here forevermore.
Bit of one of these steps again, one of these vertical bits.
The heat from the lake is intense, and the noxious gases mean we can't be here for long. We have to move fast, but the crumbling rock makes it difficult to get a foothold.
Lean back, feet apart, legs straight as you can. Oh, sorry. Oh, Tim, sorry.
Okay, no problem.
God, I really did bash you. Okay.
Everything we're carrying has to be tied onto us, or we'll lose it forever.
You just lost your hand for a second.
Oh, yeah. Got it. Just as well there's nobody below, otherwise we'd be knocking plenty of rocks down.
This lasts all the way down to the ledge now.
All right. Yeah, I bet you this will be on top of it.
The roar of the lava boiling away drowns out everything else, and it's a truly awe-inspiring sight.
You can rest your hand on my head as you stand up if you want.
Spectacular. The sound of it is amazing. Wow. That's beautiful. You know, they often say this is the eye, you know, the eye blohem, or the eye of the volcano in the local language, but it's, to me, it looks more like the heart, you know, it's just so active, so pulsing, so alive, full of the good red stuff. Wow, it's cool. That is so cool. You know, often, you know, you think of geological processes as being old and dead processes, but this is geology in action, isn't it? Wow, it's amazing. I just try and get over there.
Shane's mission is to collect rock samples from inside the crater.
Just knock down some of that to the volcano gods.
Chris will analyse them to see if any of the newer lava is similar in composition to the lava from previous major eruptions. If so, it could mean Marram is heading for another big eruption.
Come on.
Are we there?
Yes, you can see it.
Finally, Tim and I reach the ledge we've been aiming for. Getting gas samples from close to the lake will give Shane clues to understand this volcano.
What we'll do is to slowly adjust these knots so you can go forward.
I don't want to go forward, I really don't. I really don't. I just... Not yet, anyway. Let me...
I've got you.
I know, but I don't want to pull you over the edge, Tim. It's just so loose, this rock.
So now what we'll do is
I'm clinging on for what feels like dear life. But to get the best samples, I have to get even closer to the edge.
You go back to your left.
They don't want me right on the edge, do they? Right on the white rock?
This white, what is it?
Yes, that way a bit more.
Centimetre by centimetre towards the white rock.
got to be kidding.
Wherever we can get you to, will be.
Oh wow, okay. It's sort of like witnessing the beginning of the Earth. But it's the most astonishing feeling, really, to be down the crater of a very active volcano. And these glass vials on my back that Shane put there will hopefully give him some sort of clues as how active this volcano really is at this very moment.
The conditions are intense. The gas mask keeps out most of the noxious gases, but they burn your eyes and your throat, and the heat is overwhelming. So we have to go while we've still got the strength to climb to the top.
And at Nazaré, in Portugal, that interaction between the ocean and the shape of the seabed is crucial in the creation of the megawaves that our team hopes to film. Here, the waves are boosted by a feature unique to Nazaré. A feature which makes the monster waves notoriously erratic.
Unpredictability of the waves is definitely one of the toughest things about Nazaré.
For 20 years, João has been involved in a project using sonar to discover more about the mysterious underwater landscape off Nazaré. He regularly works on board the Portuguese Navy's research ship, Dom Carlos.
Vem cá, senta aqui.
Captain of the ship is Commander Barruquero.
Hi, João. What are you seeing? Hello, Commander. How are you? Well, we just started.
Sailing parallel to the Nazaré coast, at first, the sonar reveals that much of the seabed is level and shallow. But then it shows an abrupt change on a vast scale.
So in the very short distance, the bottom has increased from 100 to now almost 250 meters depth.
The seafloor is dropping away dramatically.
So we are navigating over an area that seems like a steep wall, and we continue to decrease this. 300 meters.
Still increasing.
Still increasing.
Their research is revealing in more detail just what's hidden beneath the waves. It's a 230-kilometer long canyon that runs from far out in the Atlantic towards the coast of Portugal. In places, it's 3 times as deep as the Grand Canyon, the deepest point being over 5,000 meters down. And it ends just off Nazaré. It's the position and size of the canyon which are key to the formation of the megawaves and what makes them so dangerous.
There's waves coming from different angles colliding, which also, that creates those ginormous waves. You'll see waves coming up the beach, coming down, crossing. It can be frightening.
The direction of the waves changes as they hit the edge of the canyon. This makes them collide with other waves. Where they cross, they merge to create even taller waves.
The energy of these two waves combines, and so this explains why a 10-meter swell arriving from offshore can increase to a 20-meter wave or more.
Andrew knows only too well how deadly the waves created by the canyon can be. Because in 2017, one of these waves nearly killed him.
It was a real good peak. Had that energy from the canyon. I was going to try and position myself to put myself inside the wave now, which is every surfer's dream, to get inside the wave, big barrel, and the wave just changed shape.
Andrew was flung 10 meters into the air by the immense power of the wave.
It seemed like eternity. It must have been like a split second. It was like jumping onto concrete. I knew instantly that I was seriously injured.
A rescue team managed to get him out. Andrew had broken his back. Amazingly, only 6 months later, he was back on his board.
All good?
Yeah.
Now, Andrew is going to put his life on the line once more.
Hang on, Sergio, you just need to pull out the things.
Today, the canyon is producing waves of about 10 meters, nearly as tall as a 3-story house. The team decides to put their filming plan to the test in preparation for the larger waves, when and if they arrive.
I think it's a good thing to be nervous. It means you're respecting the ocean. Definitely don't want to go out there cocky, even when it's not even that big.
With the stakes so high, Laurent and Andrew are tailed by a safety team on jet skis. If they get hit by a wave, the rescue team will only have seconds to pull them out before the next wave breaks and possibly drowns them.
It's looking good.
Laurent plans to film from the side of a wave, as close to the breaking crest as he can get. Too close, and he and his pilot could get thrown off the jet ski. To survive Nazaré's giant waves, they'll need to keep their wits about them.
It's complicated because like every big wave in the world has a channel, right? It's like it breaks and then here it's flat and here it's flat. So you can always hang out in the channel and get the shot, and here it's not at all like that. It's coming from all angles.
Okay, drone's going up.
With Laurent out on the water, fellow cameraman Peter Keith launches his high-tech drone to capture a bird's eye view of the wave.
Whoop, that was quite close to the water there.
He wants to fly right along the crest of a wave as it breaks.
Oh man! I don't believe it.
He's got too close and lost his drone.
Okay, I was right at the end of the flight as well.
It's not going well, and things don't get any better. Out in the thick of the waves, Andrew is towed out by a jet ski, so he's in the best position to catch the next one. Although the waves today are not huge by Nazaré's standards, their size and the choppy surface is making surfing and filming difficult.
Almost lost it, I hit a bump.
The camera fixed to Andrew's surfboard has shaken loose and sunk.
I think that's the first wave I've taken on the head this season.
It's back to the drawing board. They've had some powerful lessons on how difficult filming in these treacherous waters can be. And today's waves were only 10 meters high, half the height of the mega waves they hope to capture, if they eventually arrive.
Everything I've ever found out about space, the universe, physics, or science has given me an existential crisis. I'm Brian Cox, the professor one, not the sweary one, and I just finished a series called Solar System. Can you guess what it's about? They're all scary. But everywhere's scary. Venus, though, it's so horrendous. So 90 times the atmospheric pressure here, so you'd be squashed into a little pancake and then you'd be dissolved by the sulfuric acid and toasted at 450 degrees. So it's not nice. I would be delighted if we found life elsewhere, because I feel it would take some of the pressure off. Because my fear, the thing that keeps me awake at night is that life is extremely rare in the universe, and complex life is so rare that we might be the only planet in the Milky Way galaxy where complex life exists currently. So that's a guess, it's a possibility. I cannot claim, I'm not saying it definitively because we don't know. So if that's the case, then it means there might be nowhere else. So my response, if a flying saucer descended now over Broadcasting House here in London, would be one of relief. Be like, thank God that it's not only down to us now, because, you know, we're not making a very good job of it. The honest answer is, personally, I wouldn't go anywhere. I'd stay on Earth because it's all really horrible. So surface of Mars, you could stand there, you'd be okay. Mercury, you wouldn't. Venus, you definitely wouldn't. It's 450 degrees Celsius or so. Sulfuric acid rain. And actually one of the experiments we do in the series demonstrates, it's a chemistry experiment again, demonstrates what would happen to you if you skydived through the clouds of Venus. If we remove the problems away, I'd like to stand on the surface of Neptune's moon Triton. But it's this kind of frozen place with strange eruptions from the surface that kind of rise up into space but then go flat because of this tenuous atmosphere that the place has. So it's just, I would love to stand there and look out onto, with Neptune rising in the sky over this frozen surface. I'd love to do that. But I'd put a big coat on and come back quickly. I'm going to Triton, I need to get big coat. The great thing about this series, Solar System, is it's all based on new discoveries, new ideas, new data. So I learned a lot in making the series. I mean, we have discoveries, images that were taken in 2023. So it's all during filming. Something like, I can't remember the number, 40-something spacecraft currently active in the solar system. On the surface of Mars and actually out beyond the orbit of Pluto. And the idea of this series was to use the most up-to-date data, which is a great idea until you have to film the series because you're sat on a volcano, having been delivered there by helicopter. That's a cliche, but it's what people expect of me. And someone rings up from London and says, we've got a new, that thing you were going to say is not right because a paper got published yesterday. Northern Alaska, the Denali Glacier, very difficult to get to and tremendously beautiful. And we flew in, which is the only way you can get there, and flew in and landed in this old converted aircraft, a single-engined aircraft that they convert with a big engine on the front and skis on it. And this incredible pilot who has spent her life basically flying around in Alaska. She said, we're going to go over this ridge. And I was with her in the cockpit and then the film crew are behind in this. And it's like Indiana Jones and the plane goes, wow, like that, and drops. And I turn around and Julius, the director of photography, is back there. And I saw him and the camera's floating and he's going, like that, and the camera's doing that. And then he got, because everything went weightless. And then he caught it again. One of the things that I didn't know, one of the most surprising things that we talk about in the series, there's this possibility that the mountains of Venus are coated in essentially metallic snow, which is just a beautiful idea. So it shows you how the laws of chemistry that we see and experience and investigate here on Earth, they're universal, but you put them in different conditions and you get very different outcomes. There are conditions out in the solar system that we can't recreate even on laboratories here on Earth. Extremes of not only strange chemical composition but pressure and temperature that are very difficult or impossible to create here. So you can use the solar system just as a chemistry set, and there's a real sense of that throughout the series. probably in the atmospheres of gas giants. There's a form of ice that we think forms deep in the atmosphere of Uranus, the planet. Or, by the way, there's always a debate about, should we say Uranus, like the Americans, or Uranus? And then everyone else laughs because it sounds like anus. It's an electrically conductive form of ice that we think plays a role in generating the aurora that we see, like the northern and southern lights. So it's so extreme, the conditions that you need to produce this particular form of ice deep in the atmospheres of these gas giants. You get really exotic forms of matter because of the temperatures and pressures that you find there. The long shot would be the existence of life beyond Earth. We are looking actively for evidence that life existed on Mars, for example. And it's not beyond the realms of possibility, but it's aimed at bringing samples back from the surface of Mars, and that will be definitive then. The other target at the moment, we have two missions, one in flight on the way to Europa called JUICE, the Jupiter Icy Moons Explorer. It's a European mission. And then the Europa Clipper mission. Those missions are taking, I think, 6-7 years or so to Europa. And Europa is one of the prime candidates for a habitable world. So it's possible just that within 10 years we may see hints that that world is inhabited, which will be quite remarkable. I'm just going to say yes to piss a load of my astronomy colleagues off. There are a lot of worlds out there that are similar to Pluto. So it's one of many worlds out there in the Kuiper Belt. It's a historic accident that the first Kuiper Belt object we really became aware of was Pluto, and we kind of called it a planet, and so it's one of the planets. I don't care, because the thing about Pluto is it's beautiful. It's a beautiful, fascinating world. Potentially an active world. It's geologically active. And so it is possible there's liquid water below the surface of Pluto. Therefore, it's possible it may be a habitat for life, and nobody would have imagined that. And it's got mountains of ice floating on glaciers of nitrogen. I genuinely don't care what we call it. It's a fascinating and beautiful world. But I do think it's funny that people have arguments about it. It's a really important part of the series that the laws of nature that operate here on Earth, of course, they are universal laws. So the same laws of nature that govern how an egg rotates, for example, they are the laws that govern how a moon of Saturn rotates. And so we used an egg, a raw egg and a hard-boiled egg, to demonstrate some of the measurements that have been made to infer there's an ocean below the surface of a moon called Enceladus orbiting around Saturn. I did theoretical physics primarily because everything I tried to do as an experiment just broke. And so you'll see that it's the first experiment, I think, that we do in the first program. And I pick this egg up and drop it and it just breaks. And so we left that in, because that is my level of competence. And there is a serious point because they do illustrate deep physical principles. And the fact that you can illustrate physical principles and study them with just the everyday things that you find lying around is a wonderful thing. It could have rings if something hits the moon, I suppose. So it would have to be a big thing. And there's no evidence of anything big coming. I'm going to start one of those conspiracies. As far as I've been told. We do in the series talk about Mars and Mars's moons, Phobos and Deimos. The way that Phobos interacts with Mars gravitationally means it's moving in, and it will turn into a ring, we think. And that's probably the origin of Saturn's rings as well, a moon drifting in too close to the planet. But our moon is going further away, and I have no knowledge of anything. Don't put that, don't put that.
This is Bingham Mine. It produces enough ore each year to rewire every home in the USA and Mexico. It's the largest open pit mine in the world.
The size of Bingham Canyon mine continues to expand all the time. Today, we're about 2.5 miles wide at our widest point, and we're nearly a mile deep at our deepest point. As we get bigger, we move back in about 1,000-foot cuts. Those 1,000-foot cuts will take us 7 years to get to ore, and we'll continue to mine ore after that to produce the copper that we need.
Matt Lengerich is the operations manager in charge.
The earth does provide for everything that we need. If it can't be grown, it has to be mined. Whether you look at the copper that's in your house in terms of wiring or your plumbing fixtures, your cell phone, hybrid cars, copper's essential to our way of life. This is low-grade Bingham Canyon mine ore. In this case, it's a limestone ore. The shiny spots that you see in there are pyrite material.
The ore itself only contains a tiny amount of copper, so they have to dig up a lot of it to get enough of the pure metal. That's why Bingham Mine is so huge.
We've been mining for over 100 years. We've made 19 million tons of copper in that time, and we've produced about 8 billion tons of material with machines just like these.
Some seams of copper are so deep that they have to dig for 7 years through waste rock just to reach them. Everything about the mine is massive. These giant trucks each weigh more than a jumbo jet and work round the clock to remove the rubble.
I've been driving this truck for about 7 years now. It's a good feeling driving these. It's pretty exciting. They burn about 100 gallons per hour when they're driving up the hill loaded. When you're up in these trucks driving, you don't realize how big things are. The mine wouldn't make any money if it wasn't for the shovels, trucks, carrying the ore and the waste out of here.
The giant diggers and trucks are just to take the rock away. The only way to get it out of the ground is with something a little more powerful. Three blasts a day and 100 years of mining has created the largest excavation in human history.
Here's the Earth, all well separated, with all of the metals where they're supposed to be in the core. And then this planet was salted with meteorite debris that brought metals with it, including gold. That's the surprising conclusion of the origin of gold to Earth's surface.
Even though the planet had a new supply of gold, there wasn't anything to see because it was just too dilute. The gold that there was a tiny fraction of the Earth's crust, and it was spread out around the planet. It was really rare. And yet, billions of years later, a human could just pick up a nugget of gold out of the landscape. To get from one to the other, the planet had one final trick to play. With only 1 gram of gold for every 1,000 tons of the Earth's crust, there had to be a way to concentrate the tiny particles of gold into the colour we see today. And across the surface of the planet is something that can do just that. In the streams around Jamestown, prospector Brent Schock relies on the properties of water to seek his fortune, just like the original gold rush pioneers. In doing so, he's mimicking the planetary processes that finally brought us gold.
Just right over here.
So this is just dirt from the side there?
This is it, yeah.
So it's like a little ladder here and the stream's bouncing over the ladder.
That creates a low pressure area. Water slows, gold drops.
Yes.
And you've got your crevices here. You've got your low pressure areas there with the riffles. And if it's dancing a little bit, the gold can work its way down. And they will grab hold of the fine gold.
So it's getting caught just behind these ridges.
Exactly.
And then you just look through this and look for the colour.
Yeah, we look. We don't put our fingers in.
I really don't. That's me told, isn't it? So this looks really simple, but actually there's a very sophisticated thing going on here.
You're the scientist.
The stream can replicate naturally this setup here.
Yes. Constantly eroding, constantly rising and settling. Every time the water rises and then starts, you can come out here and find gold laying on the bedrock. Almost a renewable resource.
So we keep shoveling this stuff in.
You want to look at the gold. Is it coarse? Is it smooth? The smoother it is, the farther it's traveled. Then you want to triangulate your way up and find out where the vein is, where the source is. That's what everybody wants, the source of what's feeding this.
Over millions of years, water picked up gold, transported, sorted, and concentrated it, and then deposited it in a form that made it easier for us to find. It's a process that's still happening and drives our continued obsession with one of Earth's most alluring colours. This spectacular colour has been on quite a journey. These atoms have travelled from a distant star in time to be there for the birth of the solar system, and then they hit the Earth in an impact which left a golden signature on our landscape. And even then it didn't stop, because there were sorting processes, first by geology and then by water, until humans could pluck nuggets like this from the landscape. And still it carries on, because there are atoms from Egyptian jewellery or Inca trinkets that are almost certainly part of modern wedding rings or gold bullion. So the cycling carries on, but this fantastic colour stays exactly the same.